Okay, hello everyone, and thank you all to our concept reveal. Firstly, I'd want to thank you all for your presence here today and your ongoing support in Boat Twente. My name is Birgit van der Burg, and I'm the team manager of this year's team. This year's teams consist of 24 students divided into 9 sub-teams, and this is us. At Boat Twente, our mission is clear. We aim to drive sustainable innovation in the maritime sector. We do so by building a high-end race boat in which we compete in races. This requires a focus on both long and short term. And how we do so will be explained by taking you with us on a fictional race day. A typical race day consists of 2 major parts. First, we have the sprint, in which the technical team will come forward to explain you our technical goals, which are for the short term. Then, between the races, we recharge our boat, and we will also recharge ourselves. After that, the sustainability and innovation sub-team will come forward and explain you our long-term goals. But, as you all know, winners have a plan. Therefore, for every race, we write our master plan. This is something we do with the management. And to explain you more about that, I want to invite the rest of the management on stage. So, this is the complete management, and we are responsible for making the master plan and thinking about goals. And we also facilitate the collaboration between the sub-teams. My task as team manager is to oversee alignment between long and short-term goals and to foster team well-being and spirit.
My name is Dide, and I'm the technical manager of this year's team. Our technical team consists of several sub-teams who are each responsible for their own part of the boat. And it's my job to keep an overview of the work that is delivered by them, but also to make sure that they are working together efficiently. This way, we can integrate all the parts of the boat smoothly and aim to finish the year with a complete and improved boat.
Where Dida forms the bridge between every technical sub-team, I, Isa, as communication manager, form the bridge between Boat Twente and you. I make sure as many people as possible know what happens within Boat Twente. Also, I'm the treasurer. That means I'm responsible of the financial health.
And that leaves only one manager, the sustainability and innovation manager. And that's me, Koert. So that means I'm responsible for looking into which innovations can help us give a competitive edge, but also which innovations can help make the maritime sector more sustainable.
So, now that you've met the complete management, it's time to come back to the master plan. But first, we will tell you for which races we are making the master plan.
We started off in September when we had our first friendly race in Snake. Here we learned a lot about the setup of a race, but also about our task division. At the end of May, we will have our first official race, the Dutch Championships in Akrum. In this race, we are striving for a podium place.
But that's not the only race we will sail this year in Friesland. This year, we're going to do something totally different. Something Boat Twente has never done before. We are going to sail the Elfstedentocht. And this means we have to sail 180 kilometers in 3 days. It's a rare event because it's only held once every 3 years. It's quite a big challenge, but we believe we are ready for it.
And that's not the only new thing we're going to do this year. We're also going to do the Balton Solar Boat Challenge in Hungary. And although Hungary is a new environment for us, it's still a solar boat race. So we're still striving for a podium place here, as it will be the perfect opportunity to show our improvements of this year, but also to boost our reputation on an international stage. And finally, it will be an important moment for us to look back with the team at the hard work we will have put on that moment.
Now that we know in which races we are competing this year, we want to point out what goals are set to achieve the desired results. This year, the technical goals are stable foiling at 40 kilometers an hour, having a top speed above 48 kilometers an hour, and next to that, we want to improve the efficiency, but also the reliability of the boat. Later on in this presentation, the technical team will explain further about how these goals are achieved. But it's not only important what these goals are, but also how we communicate the progress towards our followers. Therefore, I would like to give the word to our communication team.
Yes, thank you, Dide. We are Wessel and Stijn, and together with the rest of the communication team, we form the connection between Boat Twente and, well, the rest of the world. Whether other sub-teams focus more on the technical side of things, we form the bridge between, well, ourselves, the rest of the world, and our fans and partners, so with you. This year, we want to continue on everything that last year's team has done, but we also want to make sure that our story is not just told, but also that it's heard, of course. So we're building on last year's team and continuing with improving everything.
Of course, our job also involves more practical tasks. For example, if somebody from our team needs a specific part or component, our extern, which is me, make sure we get in contact with the right partner to make that happen. Everything is possible thanks to you. So as you'll sit here and listen about our big plans for the upcoming year, I think it's important that you should be proud of yourself, because everything is possible thanks to you. So I would like to thank you, all partners, and of course our main partner, New Ways. Secondly, we also like to organize events to meet you in person. And this just means we get a nice space, such as this one, make sure we have a nice presentation and have a drink afterwards.
Of course, not everything can happen at these formal planned events. They simply take a lot of time to organize, as Wessel can tell you. This is why a strong online presence is also very important. And this is where Nienke, our graphic designer, and myself in our role of PR come into play. We make sure that all smaller updates, all intermediate updates, and everything in between also gets out to the world, and we have contact via social media, our newsletter, and other such things. So, if you have any idea for a collaboration, please do not hesitate to contact us, because we're always open for new ideas to share our story with the world.
And lastly, within communication, we have a brand new sub-team, our education sub-team. This consists of Roel and Stijn. And their mission is to inspire the next generation of engineers. They do this by visiting schools and open days, explaining what we do and how our boat works and why this work, what we do, is important for the future. They also aim to inspire this next generation of engineers to also undertake in a technical degree, because we are all very proud of our own technical backgrounds.
So, I think we've maybe shown the tip of the iceberg of everything that we're gonna do this year as the communication team, but I also think that's been enough talk. So it's time to start the sprint race, which is of course the mad dash to build a boat within just one single year. For this, I would like to invite technical teams to talk about their aspects of improvement, starting with Casper and Jos.
Yes, thank you, Stijn. I'm Casper, this is Jos, and together with Ise, we are responsible for the propulsion of the boat this year. Let me explain how it works. We are in charge of three main components: the electromotor, the backstrut, and the propeller of the boat. The electricity goes into the electromotor and it starts spinning. It is attached to a shaft, and at the bottom of that shaft it connects to a set of gears where it transmits the power to two other shafts going into our propeller, making the propeller spin and driving us forward. Currently, this is our backstrut. It is already 4 years old and it was designed for reliability back in the day. However, compared to some other teams, it has become a little outdated. That means that our strut has become a little bit too thick and a little bit too heavy to be competitive enough. You can imagine that a thicker strut needs to move more water out of the way than a lighter one. That means that our backstrut has become less efficient.
That's why this year we are going to make a brand new backstrut. The goal of this new backstrut is to make the strut itself and the internal propulsion system inside the strut a lot lighter and more efficient. So what are we going to change to our design? Right now our gears have a separate shell around them to keep everything tightly in place. We will remove the shell, adding it into the design of the strut itself. This will make the part of the strut behind the propeller a lot thinner. Also, we are going to use smaller gears. This will also make this part of the strut smaller. In our simulations, we saw that the stresses at the top of the strut are a lot higher than at the bottom of the strut. We can take advantage of this by making the lower part of the strut thinner than the top part. To make sure our strut has as little resistance in the water as possible, we will also change the profile of the outside of the strut. This will make it more hydrodynamic. Now, with all these implemented changes, We believe we have the most efficient and light backstrut we can get. So now you know how we propel the boat forwards. Stan and David will now tell you how we do so as efficiently as possible.
So, as Jos told you, we want to sail more efficiently. So what causes this inefficiency? Well, it all comes down to drag. Drag is caused by the hull of the boat moving a lot of water out of its way. You can imagine that a movement like this through the water will cause a lot more drag than a movement like this. So, we want to reduce the amount of drag we have. David, how do we do this?
Well, that's very simple. We just lift the hull of the boat out of the water. To do this, we use 3 wings, 1 in the back and 2 in the front. These wings lift the boat out of the water just like a plane's wings lift a plane into the sky. To show what this looks like, we have a video of our boat flying. This concept allows us to sail for longer distances and at higher speeds. However, how do we actually keep the boat out of the water at different speeds? For this, we need to change the amount of lift generated by the wings. We do this by changing the angle of the wing itself. In our case, we use a system of strong hinges actuated by electric motors. These hinges are the moving parts you see here. But as you all could have seen, the boat is already flying. So Stan, what are we going to improve this year?
Well, our main goal is to improve the efficiency of the boat. And the easiest way to do this is to make a lighter boat. Less weight means the wings do not have to work as hard to lift the entire hull out of the water. So that's why the entire team this year is working hard to make the boat as light as possible. However, a lighter boat means the current wings will no longer be that efficient.
So, this year we are designing a new set of wings, optimized for the new boat weight and a higher cruising speed of 30 kilometers per hour. To design a new set of wings, we start off in 2D. We have created a wing profile that produces as much lift as possible and as little drag as possible. This allows us to reduce the size of the wing, further reducing the drag of the wing. This profile is then put into a 3D elliptical wing shape to create the most efficient wing possible.
Another point of improvement for this year are the hinges between the struts and the wings. By simulating the flow of water around the hinges, we can optimize their shape to make them more hydrodynamic and lighter. Another point of improvement for the hinges is eliminating a side play of about 3 degrees. Eliminating this side play will increase the stability of the boat.
And with that, we have created the struts, the hinges and the wings to fly as efficient as possible. However, how do we actually control the angle of the wings and how do we make sure the boat is flying stable? This is where software and control come into play. Evan and Renske will tell you more about this.
Hello, my name is Renske, and together with Hidde, I form the control subteam. We are responsible for the computer-powered system that enables us to fly above the water. While other solar boat teams rely on a mechanical system, we actually work on a computer-powered one. A computer is capable of adjusting the boat many times per second, such that we can foil as optimally as possible. This even makes it possible for us to foil in turns, allowing pilots more time to focus on the race instead of the boat itself. This is a simplified schematic of the control system that we work on. It consists of 3 main parts: the observer, the controller, and the boat. I'll start by telling you more about the observer. Since we have a computer-powered control system, we need a lot of data. This data is obtained by the many sensors that are present in our boat. We have 3 sonar sensors that measure the height of the boat relative to the water, and 1 inertial measurement unit, or IMU. This may sound a bit complicated, but all it does is measure the acceleration and the angles of the boat. Next, I'll talk about the controller. So, now that we have our sensor data, the next goal is to let the boat follow a desired path on the water. We have our 3 inputs, namely the height of the boat above the water, the roll angle, and the pitch angle, and the desired outputs are the angles of the 3 foils that are underneath our boat. But how do we go from input to output as smoothly as possible? This is where our controller comes in. The controller is like a smart autopilot that's constantly making tiny adjustments to keep the boat steady. It takes in our sensor data, compares it to our target, and then adjusts the hydrofoils accordingly. This year, we're moving from an LQR controller to a decoupled controller. You can imagine an LQR controller like a black box. It works, but we can't easily see or tweak what's happening. In a decoupled controller, there's separate control for height, roll, and pitch, making it much easier to fine-tune each movement of the boat exactly how we want it. Lastly, I'll talk about the boat, or actually the model of our boat. In designing a controller, we use a mathematical model of our boat. The goal is to have this model represent the boat's real behavior as closely as possible. This will then result in a better performing controller. This year, we're focusing on performing several experiments with our boat to test our model, such that we can fine-tune our controller to perfection. All this will hopefully result in a stable flying boat at 40 kilometers an hour, but not only the foils and the control system have to work together, also the many other components of our boat have to communicate. Evan, can you tell us more about that?
Yes, thank you. So you've just heard about a lot of components and sensors that make up the boat, but how do they work together? Well, that's where Arjen and I come in. We are responsible for the software on the boat. Because on the boat there's a small computer. This computer is essentially like the brain of the boat, and therefore we gave it a fitting nickname, the BrainPie. So we give it a set of instructions, and this is what we call the code, and then the BrainPie knows what to do and can communicate with all the components and sensors, tell them what to do, and read out their values. But there are still a lot of errors in this code, and these small issues can lead to big problems and can even cause the whole boat system to fail. So this year we'll be working hard on reducing these as much as possible, but it's not always possible to do this. For instance, if an important component of the boat is missing, well, we're bound to get an error for that, and currently we do not get a very descriptive message for that. So this year we want the BrainPie to help us by identifying what's going wrong, by giving us a clear message, and then we know exactly what to do and can quickly fix it. So let's now go over how we turn our code into a fully functioning boat system. Until now, it was a very simple process. We wrote the code and then we sent it to the boat. But this year, we are taking it a step further by modernizing this process, because we have roughly 10,000 lines of code and currently no way to fully test it. So we'll be adding something which is called a unit testing framework. This framework allows us to test each component of the code separately, but more importantly, automatically, before it even reaches the code. That way we will be able to catch errors early on, before it reaches the boat, and we'll keep our code of higher quality. Then next up, we'll be adding a code analyzer. This tool allows us to analyze the code, and it will return a report to us, which will tell us all about the quality, so that we can keep our things organized, our code organized and clean. Both of these added steps will result in a higher quality code, and when 2 new team members will be added next year to our team, they'll be less likely to introduce new errors, and thereby directly contributing to our sub-goal, improving reliability. And then now for our final main project we'll be working on this year, the graphical interface for the pilots. Because in the boat there's a small display that the pilots use to see all the relevant data they need to make informed decisions while sailing. And this screen uses a e-ink technology display. So that's like the screen of your e-reader back home. And we really like this technology because when the sun shines down on it, it's still very clear what's on the screen. But we really wanted to improve the design on it to make it even more user-friendly and intuitive.
So now we know how all the different parts of our boat work together, but we haven't really told you anything about the bigger parts of our boat, namely the solar panels and the hull of the boat. Because without those, we wouldn't really be a solar boat. So next, the electronics and structural subteams will tell you more about this.
Yeah, thank you Renske and Evan. My name is Casper, and together with Casper and Peter, we are responsible for the electronic components of the boat. Now I'll give you a quick overview of the parts that we work on. And to do that, let's follow the path of the energy from the sunlight all the way down to the propeller. So first off, we have, of course, our solar panels. We have 6 square meters of solar panels. Now for reference, if you have solar panels on your house, you may have around 18 or 24 square meters. So for us to squeeze the most amount of energy from this relatively small area, we use these smart devices called maximum power point trackers. and they allow us to squeeze the most energy out of these solar panels. Now, the maximum power point trackers carry the electricity over into the battery. The battery holds the charge until it is needed. And then when the pilot pushes go, the motor control unit takes charge from the battery and sends it over to the motor. Now, this year we're going to be looking at the motor, but we're mainly going to be focusing on the battery. And we have 3 batteries that I would like to tell you about. First off, we have Erik, Olaf, and then a new battery. Now, to explain these names a little bit, we've named these batteries after the old partners that helped us develop these. Because even though both of these have their pros and cons, we are still very happy for the work that these partners have done with us. So first off, we have Erik. Erik is the oldest battery, but it's the one that is currently in the boat. It's a very safe chemistry and it's very robust, but it's also quite heavy, which is of course not what we want. And over time it has lost a bit of charge through our heavy use of it. So Erik now allows us to go around 8 kilometers on a single charge without using the solar panels. Now, to improve upon this, last year Olaf was developed. Olaf is much lighter and also holds a bit more charge, though still not fully the amount that we want to use. And it's also a bit less safe. This altogether means that Olaf can take us around 10 kilometers. Now finally we have the battery that we're designing this year. We want to improve upon what's already there. That means taking the best parts of both. So we want this battery to be, first of all, to keep the entire charge that we need, because we need to reach its charge limit. And then we also want it to be light. Now, making a battery light is important because when you make a battery lighter, it's almost the same as like increasing its capacity, because it allows you to be more efficient and therefore go further on a single charge. Finally, we want the battery to be safe and sustainable, because that's what aligns best with our mission as Solarboat. Now, all of this together means we want to be able to go around 12 kilometers on a charge with this battery. Now, how do we want to achieve this? Of course, we want to innovate. And for us, that means we want to look at different battery chemistries. Like right now, we're using traditional lithium-ion, but we're looking into sodium-ion or even solid-state lithium batteries. Now, these are pretty cutting-edge technologies, and they will allow us to operate right at the forefront of battery technology. And of course, that's exactly where we want to be with Solarboat. Now, apart from this, we have other projects. For example, as I said, we're looking at the motor together with the propulsion sub-team. And we're also working on redesigning the cables for the boat to make the system more robust and easier to perform repairs. We are looking into cooling the solar panels, and we're looking at redesigning the cockpit. And especially these last things we do very closely with the structural sub-team. So Ilse, can you tell us a few things about what you guys are going to do?
Yes, thank you, Casper. Hello everyone, I'm Ilse, and together with Alicia we're Team Structural this year. We are responsible for the hull of the boat, the cockpit and the cooling. Last year the current hull of the boat was made, but this year we want to improve this by making the structural integrity of the boat better, better usability for the pilots, and a better cooling system. So, but before we dive into the improvements we are going to make this year, I want to explain how our boat is built. The boat exists out of a hull, a top deck, and ribs to strengthen the boat. The hull and the ribs of the boat are made out of carbon foam sandwich, and whereas the top deck is made out of a carbon honeycomb sandwich. This also leads us to the weakest point of the boat, the back hatch. The back hatch experiences torsion. This means that it can rotate when large forces are applied. We want to remove the torsion by adding ribs into the back hatch. This is not the only improvement we are going to make to the back hatch. Right now, the current closing system of the back hatch exists out of 9 bolts that have to be screwed into the top deck and needs to be taped watertight, because there's a possibility of water entering the back hatch when we're sailing. So we want to improve the system by adding a seal and a simpler closing mechanism. One of our bigger projects this year is the cockpit. Since we will be sailing the Elfstedentocht, our pilots will be in the cockpit for at least 3 hours. Right now, they sit on tin foam mats. This is not very comfortable. Therefore, we want to design an ergonomic chair fitted to our pilots. Next to this, together with software and electro, we are going to work on the display box and the button box. We're also going to swap them, so the pilots can reach the button box more easily with their right hands. Next to this, we're also going to improve the steering wheel and the throttle, because this was a quick fix last year, but we believe we can do it even better. This concludes all the improvements we are making as a structural sub-team. But before we're going to the Enigizer, I want to quickly summarize all our technical improvements and what we're going to reach with them. So, with all the improvements we as a technical team are making this year, we aim to constantly foil at 40 kilometers an hour. We want to reach a top speed of 48 kilometers an hour, and we want our boat to be more efficiency and more robust. That concludes our technical talk, and I will give the word to Koert and Stijn, and they will give you an Enigizer.
Yeah, that's right. The sprint race is over, so our boat is now depleted, battery depleted, so we need to recharge. And our boat, of course, recharges by the interaction of the sun and the solar panels, so we're also going to do an interaction. But our interaction will be in the form of a quiz. And the winner of this quiz will actually win this beautiful goodie bag, so good luck.
All right, most of you already have seen it, but below your chairs there's green and red pieces of paper. Please grab those. Yes, if everybody has those pieces of paper, the concept is pretty simple. I'm gonna ask you all to stand up after I'm done explaining, so I can just explain it. And then we start with a simple quiz. You can choose option A or B, and if you're right, good job, you can keep standing. But if you're wrong, well, that's a shame, but you need to sit down so we can see who's still in the race and who's out. So, if that's clear, let's get to the first question.
Yeah, so please stand up as well. All right, let's go to the first question. And the first question is, what is the weight of our boat? Is that option A, less than 140 kilograms, or option B, more than 140 kilograms? So please pick your answers. The current boat. I see a lot of hesitation. But I think it's time to go to the answer, and the answer is option A. So most people have it correct, but the people who got option B need to sit down now. But currently our boat weighs approximately 134 kilograms, but of course we're always working on making our boat lighter and lighter. So this year it will be even lighter.
All right, let's move on to the next question. That's question 2. Lumina, our boat, runs on code, but how many lines of code are needed to make her run? Is it A, less than 11,000, or B, more than 11,000? Please pick your answers. All right, if everybody has chosen their answer, let's move on to the answer. It's A, less than 11,000, because it's almost exactly to a T 10,000 lines of code.
So let's continue to question number 3 then. Question number 3 is, how many sub-teams are there currently at Boat Twente? Is it option A, 8 sub-teams, or option B, 9 sub-teams? So if everyone has their answer again, then let's go to the correct answer, and that's option B, 9 sub-teams. We have 6 technical sub-teams, and then of course management, sustainability, innovation, and communication.
All right, still people left, so let's move on to question number 4. And that's, what's the most common name in our team? You've probably already heard it, there's a lot of Caspers, but are there more Caspers with a C or Caspers with a K? Please pick your answer. All right, the answers have been picked, so let's see what's the most common spelling. It's Casper with a C, so I guess that's the correct one. If you had Casper with a K, sorry.
So let's move on to question number 5 then, it's going good. And we have a question about what part of the boat is Eric? Is Eric the inertia measurement unit, IMU for short, or is Eric the battery? So as everyone has the answer, then we go to the correct answer, and that's of course the battery. Eric is of course the predecessor of Olaf, and currently our oldest battery is still in use.
All right, on to question 6. Question 6, for what speed are the hydrofoils optimized? Is it answer A, 28 kilometers an hour, or answer B, 30 kilometers an hour? And everybody picked their answers, and it is of course answer B, for 30 kilometers an hour. We previously used 2 foil types that we could interchange, but we chose to do one this year because it works just as well.
So let's get into question number 7. Question number 7 is how many blades do we have in total on our propeller? Is that A, 5 blades or B, 6 blades? And as everyone has the answer, then the correct answer is option A, 5 blades. We have 2 different kind of propeller structures, one with 2 blades and one with 3 blades, making for a total of 5 blades. But it looks like we only have 3 people left, so I think it's time to go to the tiebreaker and see who's the actual winner.
Yes, that seems like a good plan. So, for the 3 people left, the tiebreaker is going to be slightly different because it's going to be an estimation question. And the question itself is, what is the length of our current boat? Take a moment to think about it, and I'll ask the people here what you think. So, let's start with the guy in front. What do you think is the length of our boat in centimeters, please? 523 centimeters, all right. And the one behind? No idea. Do you give up? All right. 570, all right. And the last person standing, all the way in the back? 4.5 meters, I guess. Yes, all right. Let's see the answer and see who's closest. And you all slightly underestimated.
So congratulations to the woman in the white shirt. Please pick up your goodie bag after the presentation. But anyways, I feel re-energized now. I think it's ready to go to endurance race. So Nienke, Casper, please talk us to the endurance race.
Yeah, so you just all had a bit of a break, but so did the boat. It's recharged by the solar panels, and I'm proud to say that we're now ready to go on with the endurance race. So we're the Sustainability and Innovation Subteam, and we consist of 4 engineers, namely Casper, Roel, Jasmin, and myself, Nienke. And together we mainly focus on the long-term projects within the team. And with this, so unlike other sub-teams who mainly try to improve already existing aspects of the boat, we mainly focus on finding new places to innovate. So with this also our motto, innovation to inspire, comes back into play. And with this we drive sustainability and inspire sustainability within the maritime industries to, of course, innovation. So before I start talking about what we're actually gonna do this year and what we try to achieve, let's first take a step back and actually look at what we did the previous years. So 2 years ago, we were actually founded as a sub-team. And in this year, to lay a foundation, we mainly did some background research. And in the coming year, we developed this background research further into different concepts, which we're working on realizing this year. So currently we're working on 3 different projects, and Casper here is going to tell you about the first one of them.
Yes, indeed. So the first sustainability and innovation project we will talk about is a solar panel cooling system. This will counteract the performance decrease of solar panels at elevated temperatures and will come to use in the warm weather of Hungary. So we found out that on a normal Dutch day, the solar panels can easily heat up to 60 degrees Celsius, which causes an efficiency decrease of 11%. And we expect this to be even more severe during hot summer days. So to counteract this phenomena, we want to actively cool the solar panels, and we want to do this by spraying water onto them. We are currently researching how we can spray the water the best. So we look, among others, on the amount of water we spray, the size of the droplets, and the influence of, for example, wind. This will hopefully help us to sail with optimal performance in Hungary. And while this project focuses on improving the efficiency of the solar panels, we also have a project that is dedicated to improving the efficiency of the energy usage.
Yes, exactly. This second project we're talking about is sharkskin. And this can potentially have some major consequences for the shipping industries, because it can really reduce the amount of fuel that's needed to propel ship forward. Or in our case, electricity, since we're of course using a battery. So this application is already widely in use on planes, but on boats, its application is still largely unexplored, and that's where we want to come in. So I will start by telling you about what sharkskin actually is. So sharkskin is inspired by great white sharks, these sharks can swim very fast, 40 kilometers an hour, give or take. And this is partly due to their skin structure. It makes it so that they have a very low resistance in the water and thus a very low drag. And from now on, when I'm talking about shark skin, I mainly mean an inspired, mimicked version of the skin of a shark, which is artificial and has the same kind of properties. So theoretically, this can reduce the drag by 10% onto the surfaces it is applied to. And we want to apply it to the struts and the hull. And this can have some major advantages. Namely, it can reduce the energy that's needed for the boat to lift out of the water so that we can actually fly. And secondly, we can also possibly increase the speed during charging periods. And when we're charging the boat, it's usually, we're just sailing like any normal boat, we're not flying. So me and Casper have now mentioned a couple of innovations that we are doing, but not really what impact they can actually have on the world or the maritime industries. So I want to give you a bit of an example for this. So if we have a look at at the worldwide emissions, 2% of the worldwide emissions is actually caused by the shipping industries. And oil tankers are a big polluter within the shipping industries. So if we assume that we can actually reduce the drag by 10% if we apply shark skin to the hull of an oil tanker, then we can actually reduce 4.5 tons of fuel per day. This is a lot, but it's also just numbers. So let me put this a bit into perspective. This is the same amount of greenhouse gases that are emitted if you drive a car 70,000 kilometers. So this is almost two laps around the whole Earth. So with this example, you can really see the kind of impact that we can have as the solar boat and with innovations. And especially with shark skin, we can really maybe cut emissions and take a really big step towards a cleaner and more sustainable future. And about sustainability, we have another project that very closely corresponds with this. And that's our last project that we're working on this year. And I will give the word back to Casper.
Yes. So the last project we as the Sustainability and Innovation sub-team will present to you has indeed to do with sustainability. Not necessarily about the maritime sector itself, but rather on the sustainability of our own boat. We will namely create a life cycle assessment. A life cycle assessment, or LCA in short, shows you the environmental impact of each component of the boat during its whole lifetime, which starts at the production, then the distribution, the usage of the component, and at the end, the disposal. And I would like to give you two examples to get a bit of a feeling for it. So, for example, in the usage phase of our boat, well, we are powered by solar panels, which is a green source of energy. So, we don't emit anything. However, as the management team told you already, we have races in Friesland and Hungary. And, well, we have to travel there by car, which does pollute. So we take that into account. Another example is in the disposal phase. After the usage of our boat, we can either choose to incinerate some parts, which, well, does pollute and have a negative impact on the environment, or we can reuse the parts or recycle them, which will have a positive impact. Because, well, we don't have to produce those parts anymore. The life cycle assessment that we create will be a groundwork for the upcoming years, which will show us where on the boat we can make the biggest influence and which thus has priority for improvement. So, for example, we found out that we can recycle a bit more. So we will try to do that from now. And that concludes the endurance race. We have shown you 3 concepts that prepare us for the future and keep the sustainable image of Boat Twente high. It hopefully also helps us to keep competitive during races in the future. And with that, I would like to give the word back to Birgit.
So now we have almost concluded our racing day. In the sprint, the technical team came forward to explain you our short-term goals, and in the endurance, the sustainability and innovation sub-team just told about our long-term goals. So now we're sure you all know we're headed for big things. But a racing day cannot end without a drink afterwards. So therefore, I want to invite you all downstairs for a drink and to ask all your possibly remaining questions to the rest of the team. And I'd like to thank you once more, and we're thrilled to see you all again on the 29th of April at our boat reveal.